For every real number x, the floor of x over 2 is equal to the floor of x over 4. The hint says let n equal the floor of x over 2 and consider the two cases n is even and n is odd. Now, without this hint, I have no idea how anyone would solve this. So let's prove the statement. Let x be a real number and let n equal the floor of x over 2. Now, just like the hint says, we're going to break this problem into two cases. Case 1, we're going to assume that n is an even integer. So then, by definition, n equals 2k for some integer k. Now let's look at the floor of x over 2 over 2. Now by substitution, we can replace this as n over 2, since the floor of x over 2 is equal to n by assumption. And we can use substitution again to write this as the floor of 2k over 2, which is just the floor of k. And since k is an integer, this means the floor of k is equal to k exactly. Now let's look at the floor of x over 4. Now on one hand, this is equal to y for some integer that satisfies a special inequality, specifically that y is less than or equal to x over 4, which is strictly less than y plus 1. That's from the definition. We can take this inequality and we can multiply both sides by 2 to get 2y is less than or equal to x over 2, which is strictly less than 2y plus 2. So let's hold on to this inequality for now. Next, let's look at n, which is, by definition, the floor of x over 2. This is a special integer n that satisfies the property that n is less than or equal to x over 2, which is strictly less than n plus 1. And now we're going to do a trick. I'm going to take these two inequalities and do the top inequality minus the bottom inequality to get 2y minus n is less than or equal to 0, which means that 2y is less than or equal to n. On the other hand, we can look at these two inequalities and do the same trick where we take the top inequality minus the bottom inequality to get that 0 is strictly less than 2y plus 2 minus n minus 1. We can bring the n over to get that n is less than 2y plus 1. So that means this n is also less than 2y plus 1. But now let's think about this inequality here. N is some even integer, but it's an integer that's sandwiched between this integer 2y and the consecutive integer 2y plus 1. Since this inequality is strict, this means that this inequality is actually equality. This means that 2y is actually exactly equal to n. And so this says that y equals n over 2, which by substitution is 2k over 2, which is k. So what have we shown? We have shown that the floor of x over 4 is y, which is k, but k is also equal to the floor of x over 2 all over 2. This means that these two things are equal to each other, that the floor of x over 2 is equal to the floor of x over 4. Now we're not done yet because that was case 1. Next we have to do case 2. For case 2, we're going to assume that n is odd. Then by definition, n equals 2k plus 1 for some integer k. Let's start by looking at the floor of x over 2 over 2. By substitution, this is the floor of n over 2. And if we use substitution again, this is the floor of 2k plus 1 over 2. We can split this up into the floor of k plus 1/2. Now, by theorem 4.6.1, since k is an integer, this equals k plus the floor of 1/2, which is just k. Next, let's look at the floor of x over 4. Now, on one hand, this is equal to some integer y that satisfies the equality that y is less than or equal to x over 4, which is strictly less than y plus 1. Now, if we multiply this inequality by 2, we get 2y is less than or equal to x over 2, which is strictly less than 2y plus 2. Now from this inequality, we can actually identify what the floor of x over 2 is. It's either 2y or 2y plus 1. But n is an odd integer, and the only odd integer here is 2y plus 1. And so that means that the floor of x over 2 is actually 2y plus 1. So 2k plus 1 equals 2y plus 1, which means that k equals y. And that's what we wanted to show, is that these two things are in fact equal to each other. And this way we've shown that the floor of x over 4 is equal to the floor of x over 2 all over 2. Thanks everyone, and I'll see you in the next video.